Hello friends, this video on Earth block elements part 16 is brought to you by examfear.com. No more fear from exam. Now we'll take some compounds of calcium and magnesium. These are the compounds which we use in our day-to-day life. They are magnesium chloride, magnesium sulfate, calcium carbonate, calcium oxide, calcium hydroxide, plaster of Paris, calcium carbide, and calcium sulfate. Let's start with magnesium chloride. It is used as lubricant in industry. The formula is MgCl2.6s2. It has 6 water molecules attached to it. It is used a lot in industry. This is the anhydrous form of magnesium chloride. It is also used for filling the teeth. Actually, if you see, right, the dentists use it for teeth filling. And it is also used for snow removal in the street. After heavy snowfall, this is used to remove snow from the street. Talk about magnesium sulfate. This is the look and feel of magnesium sulfate. This is my with water .7s2O crystal form, and this is anhydrous without water. The formula is also called Epsom salt, MgSO4.7s2O. It is prepared from magnesite and kerosite. The formula is pretty simple. MgCO3. If you have magnesite, you react with sulfuric acid, you get magnesium sulfate, right? And it is used in medicines. It is used in the cotton dye industry. It is used to make soap and paints. It is also used as dehydrating agent. It is also used as fire to make fire resistant textile. Not only that, it is also used to make cosmetic lotions. The next is the calcium carbonate. Calcium carbonate generally occurs in the form of limestone, chalks and marbles. The limestone and the chalks, they have the calcium carbonate. You must have seen this marbles and the chalks in your life. Chalks, your teacher must be using it to teach you. It can easily be prepared by passing the carbon dioxide through slake lime or by addition of sodium carbonate to calcium chloride. So if you see, this is the first one. I have calcium hydroxide. I am passing carbon dioxide to get. I'm getting calcium carbonate. The other is I have CaCl2. I'm adding this Na2CO3 to it. It is sodium carbonate and the calcium chloride. You get calcium carbonate. So there are two ways to prepare calcium carbonate. It's a white fluffy powder. It is almost insoluble in water. And when you heat this at 1200 K, it decomposes to calcium oxide and carbon dioxide. And this reacts with dilute acid, whether it's sulfuric acid or hydrochloric acid, to give carbon dioxide. So if you want to test the presence of calcium carbonate, you can react with the acid and you see the carbon dioxide gas is the bottom now. The uses are pretty simple. It is used as a building material in the form of marbles, right? It is also used to extract iron ores. It is used for that. It is used to manufacture papers. The papers manufacturing it is used. It is used for making toothpaste, cosmetics, chewing gums, a lot of stuff. So, antacids. It is used in a lot of other things. The next is the calcium oxide, the quicklime. You see, this is how the quicklime looks. This is also CO structure. We use extensively in our life. When you hit this calcium carbonate, you get quicklime. You have discussed this equation in the last slide, right? And just since this is, if you see, this is and there's an equilibrium reaction. If you don't take out the carbon dioxide, this calcium oxide with the slake quicklime won't be formed. So what we do is we take out the carbon dioxide from this so that the reaction moves in the forward direction. So these concepts we have learned in the equilibrium reaction, where we are removing the product so that the reaction moves in the forward direction. Again, it's a white amorphous solid, something like this, high melting point, and on exposure to atmosphere, it absorbs carbon dioxide and water. Example, CO when reacts with water, it forms calcium hydroxide. Again, CO when reacts with carbon dioxide from the atmosphere, it forms calcium carbonate. So if you add limited water, not too much water, limited water to this lump, it will break this lump and it will become thick paste kind of lime, and this process is called slaking of lime. When you add limited water, please note you have to add limited water to break this lump of lime, and this process is called slaking of lime. Quick lime slake with soda is called soda lime, and this calcium oxide is basic in nature, right? Since it is basic in nature, it's basic, it combines with acidic oxides. So if you see calcium oxide, this is basic, this is acidic, it combines to form calcium sulfate. This is basic, this is acidic, they combine at high temperature. We'll see some uses of calcium oxide. First thing is it used to form cement. In the cement it is used, it is also used to manufacture sodium carbonate. It is used in the purification of sugar. It is used for dyeing stuff it is used. The next is the calcium hydroxide. It is prepared by adding water to quicklime. So I have seen calcium carbonate. From calcium carbonate I got calcium oxide, right? And from this only I'll get calcium hydroxide. And it is also white amorphous powder. Let me give the reaction of forming CaOH2. So I have CaO, I react with water, I get CaOH2. Correct? You have this quicklime, react with water, you get CaOH2. It is sparingly soluble in water, and the aqueous solution is called the lime water or milk of lime. When the carbon dioxide is passed through this lime water, it turns milky. And this is the test for carbon dioxide we use in lab, where we have this lime water, right? Here is lime water, there's nothing but CaOH2 in water. We pass the carbon dioxide to it, it turns milky. Why? We have CaOH2, you pass CO2, it becomes CaCO3, it is milky in color. And if you pass too much of carbon dioxide, what will happen is this calcium hydrogen carbonate will precipitate. So you have this calcium carbonate now here, you add more and more carbon dioxide, you get CaSCO3. This is a test used in lab to find carbon dioxide. Milk of lime, my CaOH2, it also reacts with chlorine to form hypochlorite, which is used for creating bleaching powder. Right? So CaOH2, if you add with chlorine, it gives calcium chloride and CaOCl2, that is hypochlorite. There are a lot of uses for calcium hydroxide. It is used to prepare mortar. Mortar is this mortar which is used to join the bricks, right? You must have seen this mortar which is as a glue which joined the bricks in the wall. This is a wall actually, and I have shown you some 2 or 3 bricks. This is a cross section where you see the mortar has this. This is the mortar which holds these bricks together. It is used for whitewash, for disinfect. For example, if you see these trees, right, they have put this calcium hydroxide here. Why? Because else the tree may catch termite. So if you keep doing what, in fact in house also, if you see a lot of people do whitewash. So if you do whitewash, what will happen is all the germs will go off and your house will be clean, right? It will be germ free. So it has this disinfectant quality also. It is also used in making glass. It is also used in purification of sugar, and also used for making bleaching powder. The next is the plaster of Paris. So we have read gypsum CaSO4 2H2. This is CaSO4 half H2. So how to get CaSO4 half H2? You have this CaSO4 2H2 is gypsum. You heat this below 393 or almost 393 Kelvin. You will get this hemihydrate calcium sulfate. That is nothing but plaster of Paris. And you must have seen this plaster of Paris, and it is used for if your hand is broken, leg is broken. So in that case, we use the doctors use plaster of Paris. Right? But if you heat above 393, all this water molecule will go off, and this becomes anhydrous calcium sulfate, right? And this is called dead burnt plaster. The moment you mix some water to it, it will again become plaster. But if you heat it very hard, it becomes dead burnt plaster. If you see the reaction we have, calcium sulfate, if we heat very hard, right, 393, it gives CaSO4.H2. And it has a very high remarkable property of setting in water, and that's why it is used for plaster of Paris. So if you mix this plaster of Paris with sufficient amount of water, it forms solid mass in 5 to 15 minutes only. In a small amount of time, it forms solid mass, and that's why it is used in this hospital to cure the fracture. Let's talk about the uses of plaster of Paris. The one uses is for the ceilings. If you see the false ceilings in the house, we use plaster of Paris to prepare that. It is also used in the bone fracture. It is also used to create the statues, ornament work, cast, and all those kind of stuffs. Next is the calcium carbide. This is also produced from CO. So, and you have the CO, you take the carbon, you heat it up. in the ratio 2:3 at 3300 K, you get CaCO2, calcium carbide. It is colorless crystal. It is easily attacked by air. The moment you add water to it from the air, you get COS2, very, very reactive. It has two uses. One is it is used in the preparation of acetylene, and another is it is used as a good reducing agent. The next is calcium sulfate, CaSO4.2H2. It exists as anhydride form also, where without water and gypsum, CaSO4.2H2. If you remember, this only when you heat, you get the plaster of Paris. The uses are to make plaster of Paris. We have discussed the plaster of Paris. It is also used for treatment of soil, and it is also used to prepare sulfuric acid. Sulfuric acid is a very critical acid. Acid we use in lab, we use in industry. So calcium sulfate is used to prepare sulfuric acid. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.